Welcome to Pharma Drama, the channel where we look at the science of healthcare and healthcare products. In this video, I want to explain a new type of manufacturing that seems to be changing every sector it's used in, especially medicine, and is very popular in the media: 3D printing. I'm sure you've heard of 3D printing or read about the amazing things that have been 3D printed, organs, body parts and that sort of thing. Maybe you're interested to know how the technology works, or maybe you're thinking of buying your own 3D printer and you're not sure where to start. In any case, I'm going to explain the basic principles of 3D printing here. So, if that sounds interesting, get yourself a drink, print yourself a chocolate, and let's make a start. I think it's easiest to begin by considering a type of printer you are probably familiar with: a desktop inkjet printer. Say you've been on holiday somewhere and you have a beautiful picture from the terrace of the villa you were staying in, showing its magnificent views across a valley, and you think it would look good framed on a wall in your house. You upload the picture to your computer, press print, and as if by magic the printer produces the image. You have probably never thought of just what a marvel of engineering your printer is, but I can tell you, a typical inkjet printer can produce up to 10,000 droplets of ink per second, each with a volume of only 2 to 4 picolitres. That's very small. 1 picolitre is 1/1,000,000th of a litre. A 2 picolitre droplet is about the same size as 200 red blood cells. It jets droplets from 3 colour cartridges and it deposits these on a piece of paper with exquisite precision to print your holiday snap. Because the image it produces is a single layer, we call this type of printing two-dimensional. If we were to print many images on top of each other, I think you might imagine we would start to build up a three-dimensional object. Obviously, we would need many layers, because a layer of ink is very thin. But hopefully you get the basic idea. A 3D printer works exactly like this, building up an object layer by layer. It can use an ink, but usually other materials are printed that allow objects to be built faster, as I shall discuss in a moment. Sometimes 3D printing is referred to as additive manufacturing, and while I don't think this term is quite as catchy, it does help in understanding how the process of 3D printing works. Think first about conventional manufacturing. Since humans invented tools many thousands of years ago, we have made things by starting with a block of material, like wood or metal, and removing material to fashion our object. Originally, this might have involved using sharp stones to whittle down a stick to a point for hunting, and now we have lathes, mills, water jets, lasers and so on, to allow us to remove material and make objects. In this sense, we can think of conventional manufacturing as subtractive. We start with a block of something solid and we remove material from it to make our object. 3D printing turns this paradigm on its head. We start with nothing and we add material layer by layer to create our final object. And this is why the term additive manufacturing is used. We add material from the printer where it is needed to create our object. In that sense, the printer is really a glorified dispensing machine. Think of pulling the handle on a soft scoop ice cream dispenser and extruding the ice cream into a cone. A 3D printer does essentially the same job, but on a much smaller scale, and so we can create objects with much greater precision. How does a 3D printer know what to print? Like any printer, it is sent a set of instructions by a computer, telling it what to print. Rather than the instructions being for an image or some text, as would typically be the case for an inkjet printer like I mentioned at the start, a 3D printer requires information on what is to be printed to make each layer of an object. Effectively, once the object to be fabricated has been designed, it must be sliced into a series of horizontal layers. The easiest way to do this is to design the object in CAD software. there are loads of software options available that you can use to design three-dimensional objects. A good option that is web-based and free is Tinkercad, and I put a link to their website below. If you don't want to design your own objects, then there are many designs available on the internet that you can download. I like Thingiverse, and again, you will find a link for that below. When you press print, the software automatically slices your object into horizontal layers and sends the information for each to the printer. Note, I keep saying horizontal layers. This is because all 3D printers, irrespective of how they work, have to print each layer horizontally onto a build plate. Gravity holds each layer in place while the next one is printed. Now, I hear you ask, does a 3D printer make objects out of metal, or ceramic, or plastic, or resin, or powders? The answer is all of them. There are loads of types of 3D printer available. While they all operate on the layer-by-layer principle I discussed earlier, what they print and how they solidify objects can be very different. What do I mean by solidify objects? Objects that are 3D printed are solid. There is no point trying to print a liquid or gas. It would make a mess. But how can a printer dispense something that is solid? The answer is, it doesn't. The really clever part of 3D printing is in how the printer takes a raw material. I call it a feedstock material. Think of it a bit like the ink in a desktop printer, which it must be able to dispense and turns into a solid. The first type of 3D printer, known as powder bed printing, was really a type of inkjet printing. It combined an inkjet printhead with an apparatus that could dispense powders. Rather than contain an ink, the printhead contained a solution of glue. To make an object, a layer of powder is spread out on the build plate and the printhead passes overhead, spraying glue to stick the powder particles together, forming one layer. Then a new layer of powder is spread out over the first and the process repeats. At the end, the object can be removed from the build plate and any loose powder can be shaken off. One limitation of this type of printer is that it cannot print hollow objects because the loose powder will be trapped inside. Currently, there are many other types of 3D printer available. I will discuss some of these in detail in other videos, but for now, I'll give you a few examples. Remember, they all work by having some sort of feedstock material that can be dispensed and then set solid in some way. The most common type of 3D printer, and you may have one at home, is fused-filament printing. In a fused-filament 3D printer, the feedstock material is an extruded polymer, much like a thin piece of string. You can buy them on spools. The filament is fed into the printhead and melted, turning it into a thick liquid. This liquid is then extruded through a small nozzle onto a build plate. The build plate is kept cold, so when the liquid polymer touches it, it turns back to a solid. The nozzle moves across the build plate in an XY raster pattern, building up the first layer of the object. Once the first layer is finished, the build plate moves down and the process repeats for the second layer. In this way, the object is created layer by layer. This was the first type of printer that we bought for our own labs, and we use it for printing pharmaceutical tablets, which we term printlets. We can make a printlet in around a minute, and we can tailor the amount of dose each contains to individual patients. There will be a separate video where I discuss how you can print tablets later on. You may have seen it's possible to print food. The 3D printers that can make candies, chocolate and other foodstuffs also work by heating the feedstock material to make it a liquid, or at least solid enough to extrude. If we take chocolate printing as an example, a block of chocolate is placed into a syringe and heated so that it melts. When you want to print an object, the syringe plunger is pushed down to extrude the chocolate through the printhead nozzle onto a build plate. Again, the build plate is kept cold to solidify the chocolate, and the object is created layer by layer. Another way that objects can be made is with a laser, and here two methods are commonly used. In the first method, known as stereolithographic or SLA printing, objects are made from a resin, and a laser is used to photo-cure molecules together. The resin contains small molecules known as monomers. Because they are small, they are usually liquid at room temperature, so the printer holds the resin in a tank. When a laser is focused into the resin, the energy it contains chemically excites the monomers, causing them to react and bind together. When monomers react like this, they form polymers. As the polymer chains get bigger and bigger, they become solid. To create an object, therefore, the laser moves in a raster pattern through the resin, solidifying it to create a layer. Then the resin tank moves down and the process repeats. As always, the object is created layer by layer. We also use SLA printing to make printlets. Some examples are shown on the screen, where you can see the initial CAD design and the actual printlets. The second way a laser is used in 3D printing, known as laser sintering, is to heat particles up and cause them to fuse together. Much like the powder bed printer I mentioned earlier, a layer of powder particles is spread out, but rather than using an inkjet printhead to spray a glue, a laser beam is moved over the particles in a raster pattern. The energy in the laser heats the particles up, causing adjacent particles to fuse together. Again, the laser is used to create the first layer of the object before a second layer of powder is spread out and the process repeats. The laser can be so powerful that even metal powder can be fused in this way, which is how 3D printing is used to create metal objects. But we don't use metal particles in medicines. No one wants to take that sort of iron tablet. Right, those are the basic principles of 3D printing. It's termed additive manufacturing because objects are built by adding material, not removing it. Objects to be printed are designed in CAD software so they can be sliced into horizontal layers. The information for each layer is sent to the printer, which then deposits the required material. Although there are many types of 3D printer, all need to dispense a feedstock material and then solidify it in some way. In the healthcare sector, we tend to print polymers, gels and powders, but it's also possible to print metals. I hope you found that brief description useful. If you did, please hit the like button and consider subscribing. It really helps promote the channel. I will look at specific types of 3D printing technology in separate videos, and I will also discuss some of the medicines we print at UCL. We have a lot of 3D printers. However, if there are specific topics related to 3D printing that you'd like me to explain, please leave a comment below. Otherwise, thank you so much for watching, and I'll see you again soon.